Good morning, my name's Bob Willis and welcome to SMTconnect here with Winnie TV. And it's a pleasure to have Harald back again and the opportunity to talk to him about everything inspection. But Harald, would you like to first introduce yourself and also what the company does?
Okay, my name is Harald Eppinger. I'm the managing director for Koh Young Europe, a subsidiary from our headquarters in Korea. We are mainly focused on inspection system and everything around, but even more we are going also around the SMT into the other applications like pin inspection, conformal coating, so everything around measurement, and it's moving from the inspection into measurement and 3D measurement, and the goal now on the trend is very clear: process visualization, process optimization, utilizing the data of the machinery what you have in the SMT line.
Okay, one thing I must raise, I get frustrated sometimes when engineers say, you know, I've got this data, I've got this information, and I said, have you looked at the board?
Yeah.
Please, as an engineer, use the facilities you have, use the data, because that's extremely valuable, but also look at the problem. And do you come across that?
I would say yes. What we like to emphasize and underline, and we had some workshops with big guys in the e-vehicle industry. I raised, if you hunt the defect, today you are already lost. If you hunt the deviation, you are on the right way, on the right track. So I agree, you have to look on the defect at the end of the day because it's the result. But it's more important to get the trigger on time, to pay attention on something and to see the deviation. And if you, we are all long in the industry, we have seen the changes, and we have been able to have hands-on and repair. But if you look to the future structure of PCBs and the semicon, the back end and the smaller structures in the PCB, they are merging, they are moving together. It was impossible to think about the structures we are talking today. But the repair is impossible. A defect is not just a not soldered part, it's just a slightly offset of a component, because the gap between the components are so narrow that it's extreme. So I would say you're right. You should never underestimate the impact of a defect. But today, seeing what's happening, that somebody is destroying the process quality or improving the bandwidth of a process, and due to the labor shortage is even more. You don't have the people anymore who smells the defect even an hour before. So the people coming from the university, they need tools to get the right direction to act and to learn on the job different that we did.
And the point that you raised, that the newer engineer is used to dealing with data, is used to looking for trends in data. And the point also you raised quite rightly is when you've got a defect, you've lost. And if you can see it early,
expensive.
It's more expensive. So in terms of the semiconductor side of things, what's sort of an area there that you feel that is a growth area for you?
So I would say definitely we are clear in the back end. It starts earliest with wafer bumping inspection, but it's mainly the packaging and the stacking, and when this is really what is currently booming. It's a reshoring to Europe. We see all big players are back in Europe. We see a lot of activities. Unfortunately, if I compare with my American colleagues, they are much faster. We have the same time the CHIP Act, we have the same time the willingness to go forward, but we are slower in Europe. But we see packaging is coming, and AI is forcing for more memory, for more new technology, and this kind of stacking is really fantastic. If you look at the density of this board, I get a smile because it's fantastic what you can integrate meantime. The packaging area is definitely important. That's why we also focus on the semicon shows worldwide.
So back to traditional SMT assembly. Obviously, there's been an increased interest in conformal coating inspection over the last few years. Is there one particular market sector which is pushed companies to have automated?
Yes, I would say the main trend and trigger is currently around automotive, especially driven by e-vehicle. You know, the conformal coating was used to cover from humidity and contamination, but due to the higher voltage above 800 volt or 800 volt we are currently talking about, it's also a matter of isolation. So you have the control parts and you have the power parts, and you see all around here this power electronic becomes a topic. It's really, and here you see a clear need to protect from different aspects.
Yeah, I mean, a couple of years back I used to do regularly work with the National Physics Laboratory in Teddington in London, and it was just interesting how standards need to change, test methods need to change for the new products and the new criteria. And particularly having safety interlocks on electrical test where you're talking about significantly high voltages, as you said, for the electric car market. So it's just interesting how things have changed. Just back to, let's say, solder-paste inspection. It's something that you've been involved with, pretty much right from the start. Have you seen anything that's changed there apart from miniaturization? Anything that's changed?
Yes, definitely. So the only thing what has really changed is let's call the challenge of the PCB, because we are talking currently. We have boards with 0.3 millimeter thickness and balls with 30 micron, and that means the miniaturization, but also the development that this thin PCB, it looks like a semicon application, but it's a PCB. Yeah,
it's flexible.
It's okay. Sorry, it's definitely flexible. Yeah, and we when we talked about flexible board, it was always a challenge. The carrier, the right transport, and today it's not. It's only flexible. So and then we are not talking about the variables. They are even more flexible. So this kind of changes and trends you see is a kind of very interesting development between the miniaturization and utilizing the experience we had to deal with these things. And it's, I would say, beside the miniaturization is the board handling, the takt time, and the density of boards. Because suddenly we are talking about 1,200 arrays, 1,400 arrays, but the board is just 100 by 200 millimeter. So it's fascinating numbers what you're dealing suddenly with when you had a double board or just the sizes and the consequences, what you have to expect, what is influencing the process quality. Yeah, damaged carriers, some nozzle which are not providing the right vacuum and has creating a disaster. So watching the deviation, what I mentioned before, through the tools you can utilize, helps you. This called preventive maintenance, but also what everybody likes to do, the mainless factory or light off factory. It's all small steps. We are far away from this, but we are getting closer to some of the milestones, I would say.
It's interesting you mentioned about carriers, because people take carriers as a tool to take the board through a process, but they never think, well, hopefully now they do actually do maintenance on the carriers.
Yeah.
Because I remember sitting in a factory watching product go through and actually putting a mark on the carrier where they had a defect. Okay?
Yeah.
And then after 3 hours, this pallet came back again and you could see I put 3 or 4 marks on it.
Yeah.
And that was the problem. So maintenance, I think, is important, or engineers need to understand that.
Let me underline exactly this point. We are offering now KPO for our software tool, KPO for printer and KPO for mounter. It was always the discussion between SPI and the printing process about offset and some corrections. But meantime, we are running a DOE to optimize the setup. Then we keep the values ongoing during the process. But we just released the option for KPO for mounter, where we identify even a nozzle or a feeder or a carrier, whatever it is, to watch carefully on the deviation and then to replace the nozzle on time without going for the full maintenance. So we just tell the printer, the pick and place machine, nozzle 17, park, and then it's parked. It slows down a little bit the throughput. Nozzle is exchanged or cleaned and comes back after a few minutes. This is the mega trend, I would say. Keep the efficiency high from the lines, and telling the people, you mentioned it as a carrier, we are now at a nozzle level or even a reel or any mechanical part on the mounter we can identify as a problematic root cause, and we can act, and I think that's the future.
So what about, I think I might have asked the question before about robotic soldering. Is that something that, I mean, you've got the tools to be able to do through-hole inspection, but have you seen an increased use of robotic soldering that is required inspection?
Look, I would compare it with the press fit. When you look at the history of press fit, it comes, it goes, it comes, it goes. Everybody was telling THT component, wave soldering will disappear, and it's still a valuable part, a valuable method, and the robotic soldering, there's not a big difference. There's more solutions coming, more intelligent solutions coming. For us, it's another solder joint to measure and to trace. I would say yes, it's increasing, because through the press fit combined with high power, you need a different connectivity. So the classic soldering is one of the solutions. But I have to say, similar to press fit, it's also coming, and there's a balance between the trend. Either the product goes into press fit direction applications or stays with the classic soldering.
As always, Harald, it's been an absolute pleasure.
Thank you.
Thank you very much for the interview, and hopefully another successful show.
Thank you. Thank you very much.